in action. I know many of your students take that course as an introductory science course. I teach it online in the spring semester, and I taught it online in the August intercession course. Many of students, as I'm sure many of you are similar, is that they don't have any exposure to geology before they start. It's known as the easy science, not as hard as physics and chemistry, but it's not really, really easy. They talk about rocks, it's dusty stuff, you know. So my main approach to the course is to just get them to understand what planet Earth is all about. You know, this thing, climate change, that we hear on the news all the time. What is that even, what that even is? One of the main goals of my course is to tell students to relate to geology as it means to them. You know, you can think about the pictures that I've put here. It could have any kind of meaning. You can think about the rock that was in your parents' house in the backyard, and you always climbed on it or down. What was it? Why is it there? And things like that. So the point that I'm trying to deliver in this presentation is that maybe textbooks and recorded videos of instructors are not always the best resource to deliver material. Because of the topic that I teach, it's very out there, involved in politics and stuff. There's a lot of introductory videos that I have came to know about because I was developing an open alternative book, textbook. So it just serendipitously worked out that I learned about the TED lessons. The reason why I don't record a video of myself describing the topics is that, first of all, I have an accent, and I'm sure nobody wants to look at this hair for 45 minutes. Those records are time-consuming. You have to close caption it. And if you want to make any changes, oh dear God, you have to redo the whole thing. And it's boring. I mean, it's the most mind-numbingly boring thing ever. I'm one of those millennials that sit in your classes, and I can testify that it could get really, really boring. But the people who make these videos are brilliant. So I want to show you one of a little bit of some of the videos and how they're interesting. But just at the front page of the TED Lessons on Earth and Space Sciences is the topic of fracking, which obviously is one of the things that we talk about. The TED lessons are developed with questions and discussion questions, so there are actually some ideas that are delivered with the video itself. So you don't necessarily have to start from scratch. There is some ideas that are put out there by the people who developed the video and the lessons with it. So the pros and cons of using pre-developed videos is that they're very interesting animations, and they could explain the most complicated topics in the most simplest way. One of the examples that is in this video that I'm going to just show you briefly is explaining what the chaos theory is related to modeling climate. Modeling climate is one of the most complicated things that anybody has ever done, and it relates to chaos theory, so the video explains that really well. But before that, this is my most favorite video because it has this Japanese person who developed it, and everyone in the video carries an umbrella. There's no face. And
that building collapse is caused directly by the ground beneath them.
All sorts of Japanese text in it, which I find it really cool. This is about building stability during earthquakes. There is a animation, again, the umbrella. I think it's hilarious. And there is God, where's the monster? Oh, there it is. There's this monster that is moving the building instead of like showing the shaking of the ground, and it's about the oscillation of the building. So it's very cool to be looking at this and learning why do buildings fall in earthquakes. The other video, oh, I have to copy it now. I'm running out of time. What am I doing? All right. The chaos theory is explained through a billiard or a pool table theory, which is, I think, again, it's brilliant to explain how the chaos theory works. And again, this is right now referring to the shape of that pool table and how that could impact what the outcome of the motion is. There we go. All right, not to go too much off topic, I'm just gonna pause this. But of course, there's some cons to this. There's sometimes incorrect material out there. This particular video that I'm not gonna go to explains the motion of hurricanes, but it's from PBS. It starts right, but at some point they just lose it, and it doesn't work out. And also, of course, for all the topics that we teach, there's not an educational video for everything. So it becomes a little bit of an issue. It's just, you just need to find the right resources for that kind of material. TEDed is not the only resource. For us, the United States Geological Survey has this amazing educational resource that they already have pre-developed courses, and they have like informative web pages, such as induced earthquakes or what we now know of fracking. So there's a lot of information that you can find from open alternative resources that could make your course material very interesting. And the way I use these videos is that I actually make quizzes out of them. I give them enough time, no time limit, just to watch the video, enjoy it as much as I did, because I really do enjoy watching these videos. And I give them questions to answer. And these questions are the questions that appears on their exams, and makes it a little bit less boring. All right, thank you.